Good morning, everyone. Today, I will introduce the Harmony Res System project. Our mission is to construct a modern, double-story single-family home located in the heart of the SS17 residential area in Subang Jaya, Selangor. Our primary goal is to deliver a residential that is not only safe and functional for its future inhabitant, but also fully comply with all Majlis Bandaraya Subang Jaya regulation. To ensure this project meet the highest standard, we have appointed a dedicated project management team. This team is responsible for overseeing the entire life cycle of the build, from the initial initiation phase right through to completion, which include developing a robust project charter, identify and engaging with key stakeholders to ensure smooth communication, and managing site logistics and safety through a comprehensive site layout plan. Project charter have included some key components, which is project background, objective, scope, stakeholder, risk, and constraints. For the background, the Harmony Res System project was born from a need for a modern 3,000 square feet double-story home in Petaling Jaya for our client, Mr. John Snell. Our goal is to provide a smart, energy-efficient home that stands out in the current market. The scope is comprehensive. We are delivering a full design and build for a 4-bedroom, 3-bathroom res system. This includes all architectural, structural, and MEP work finished with premium material like homogeneous tile and wood flooring. Next, the project objective. We have defined 3 clear success criteria for this project. For the first is time. We aim to complete the build and sequence the certificates of completion and comply within 12 months, specifically by 31 December 2026. For the cost, we are committed to staying within a strict budget of 815,000 ringgit. For the safety, our target is zero accident or lost time injury throughout the entire construction phase. To achieve this, we have assembled a strong team, which include the owner, Mr. Jong Snell, Project Manager Construction Pro Sandira Berhan, Architect JCS Design Project Sandia Berhan, and the Authority MPBJ, which is Petaling Jaya City Conscious. For the component of project constraints, first we are operating under a fixed budget of 815,000 ringgit. This is a hard cap, meaning our resources allocation and procurement must be incredibly focused to avoid any overrun. Second, we have strict operational window. Construction and on-site activity are limited to Monday through Friday. From 8 a.m. to 6 p.m., we have no weekend or after-hour flexibility, which put a premium on daily productivity. Finally, from a regulatory standpoint, we must strictly adhere to land use setback, which specifically a 20-foot front setback and 10-foot side setback. This is non-negotiable for MPBJ approval. Now, let's look at the risks we need to manage to keep this project on track. We have identified 4 key areas of concerns. Firstly is permit approval. Our first hurdle is potential delay in MPBJ permit approval, which could put back our start date. Secondly is neighbor complaint. Since we are in the residential area, noise and dust are major factors. Too many complaints could lead to fine or a forced stop to our work. Next is traffic congestion. Traffic in Petaling Jaya is a real challenge. This can cause delivery delay for critical material like concrete and steel. For the labor shortage, finally there is a high demand for skilled workers in the Klang Valley right now. This makes it harder to find the right team and could increase our costs.
In this section, we identified the key stakeholders for the Harmony Residence project to ensure clear lines of authority. We have classified them into 2 groups. First is internal stakeholders. This includes our client, Mr. John Smith, who provides the capital, and ourselves, Group 1, acting as the project management team responsible for execution. Next is external stakeholders. These are our partners and regulators. We work closely with Ms. Xin Yi, our architect, to ensure all designs meet MPBJ standards enforced by Haji Muhammad Dari. For the actual build, we have appointed Mr. Li Chonghui from HG Service as our main subcontractor. In this part, we established a functional organization structure. At the top, we have the project sponsor, Mr. John Smith, who holds the ultimate authority. Reporting directly to him is our team, Construct Pro Sadirin Bahar, acting as the project manager. We serve as the central hub, coordinating with Ms. Xin Yi, architect, for design and technical issues, MPBJ for regulatory compliance, HG Services for the actual physical construction on site. This structure ensures that all instructions flow through the project manager to avoid confusion on site. For this communication flow section, we established a communication matrix to manage the tight 12-month schedule and the residential site constraints. Internally, we have daily briefing with our subcontractors to ensure safety and workflow on site, and weekly technical meetings with our architect to resolve design issue quickly. Upwards, we report to client Mr. John Smith on a monthly basis regarding budget and schedule performance. Externally, we have a critical line of communication with MPBJ for milestone inspections and with the neighbors to manage compliance regarding noise or dust.
In this part, we will learn more about WBS. Basically, what is WBS? WBS is Works Breakdown Schedule. It is a hierarchical decomposition of project scope that will break the project into a smaller work package. For Harmony Resident construction of double-story single-family house, WBS serves as fundamental project management tool to facilitate effective planning, scheduling, cost, and control to ensure that no activity is overlooked. Each package will represent a specific task in this project. Next is objective of WBS. It is to clearly define project scope. Second one is to organize construction activities systematically, and it is also to assist in time and cost estimation so that the project will not be delayed and over budget. And it is to improve monitoring and controlling, and the last is to enhance communication among the stakeholders so that the stakeholders will be informed the progress of the project. The WBS for this project is organized into 7 principal levels of corresponding to major phases of the construction life cycle. Each level is further subdivided into work package representing specific construction activities. This hierarchical structure enables clear definition of responsibilities, accurate resource allocation, and systematic progress monitoring. Firstly is mobilization and authority approval. These phases encompass initial project establishment and regulatory compliance. Preliminaries include site mobilization and the provision of temporary site facilities necessary to support construction operation. Statutory approval involves submission to Majlis Bandaraya Petaling Jaya (MBPJ) and the application to utility authorities such as TNB, Tenaga Nasional Berhad, Air Selangor, and Indah Water Consortium, which is AWK. Project management and compliance activities focus on project scheduling, coordination, and implementation of safety, health, and environment system to ensure adherence to statutory requirements. Second is foundation and substructure works. These phases comprise all below-ground construction activities. Site preparation includes site clearing, setting up, and excavation works. Substructure construction involves piling operations, followed by the construction of the pile caps and ground beams. Foundation works consist of footing, base slab, construction, and concrete works, including curing process to achieve the specific strength and durability. Third is structural frame. This phase focuses on the formation of the primary load-bearing structure. Ground floor work include the construction of column, beams, and floor slab. First floor work involve the erection of upper level column, beams, and slab construction. Structural quality control activities include reinforcement inspection and the concrete testing to ensure that it complies with the design specification and relevant standard. Fourth is roofing and weather tight envelope. This phase aims to achieve building enclosure and weather protection. Roofing works include installation of roof structure and application of roof covering with waterproofing system. External envelope work consists of external walls construction, cladding, installation and installation of walls and external doors. Weatherproofing measures include sealant application, flashing installation, and water tightness testing to prevent moisture ingress.
Going to the fifth one is mechanical and electrical first fix and internal plastering. This phase involves installation of concealed building services. Mechanical and electrical first fix work include installation of conduits, wiring, air conditioning, and ventilation ducting. Plumbing and sanitary first fix works involve installation of water supply, sewerage, and drainage piping. And lastly, internal plastering works include wall plastering and ceiling base preparation. Next, the sixth one is final finishes and quality check. This phase emphasizes architectural completion and service installation. Architectural finishes include door finishes, wall finishes, ceiling installation, and installation of door and windows. Mechanical and electrical second fix works involve installation of light fittings, switches, socket, and sanitary fixtures. And lastly, testing and quality control activities include system testing, commissioning, and defect rectification. The last one is project handover and certificate of completion and compliances. This phase represents the final stage of project completion. Final inspection and documentation include preparation of as-built drawing and operation and maintenance manual. Alternative certification involves submission for the CCC and conducting final inspection by relevant authorities. Project handover include formal transfer of the completed facility to the client and project closeout activities. In conclusion, the development WBS provides a comprehensive framework for managing the Harmony Residence project. By systematically decomposing the project into clearly defined phases and work package, the WBS enhances planning efficiency, facilitates effective monitoring and control, and contributes to the successful delivery of the project in accordance with specified objectives.
Now, I'll explain the site constraint and planning consideration that affect the site layout, construction process, and overall project management. First, I'll talk about the site location and surrounding environment. The project site is located in a mature residential neighborhood in Petaling Jaya and is surrounded by occupied double-story landed houses. Because of this, the site is highly sensitive to construction impact such as noises, dust, vibration, visual intrusion, and increase in traffic movement. Compared to an isolated industry site, this location faces much greater public security, and there is also a higher risk of resident complaint being made to MPBJ, which could result in inspection or even temporary work suspension. As a result, several site layout controls are required. These include the provision of perimeter hoarding, control access points, and effective dust suppression measures. In addition, construction activity must be carefully sequenced to minimize disturbance to surrounding residents, especially during noisy work. Second, I will discuss site access and traffic condition. Access to the site is via a very narrow residential route. Traffic along this route is moderate to heavy during peak hour. So this creates a logistical challenge for concrete truck and material delivery lorries as the space is limited. If not properly managed, this situation increases safety risks to nearby residents and other route users. So to manage this issue, several mitigation measures are proposed. Material delivery will be scheduled during off-peak hour and a just-in-time delivery strategy will be adopted. Entry and exit point will be clearly defined and adequate internal circulation route and unloading area will be provided to reduce congestion and improve site safety. Next, I'll explain the planning and regulatory constraints imposed by the local authority. The project is subject to MBPJ planning and building control requirement, which including a 20-foot front setback and 10-foot side setback on both sides. This requirement reduces the buildable area and usable site space. In addition, the project must comply with regulation related to noise control, dust suppression, proper waste disposal, and traffic management with appropriate signage. Because of this requirement, the site layout must be carefully planned. Temporary facilities need to be position efficiency, and the overall layout design is driven by compliance with statutory regulation. After that, I'll move on to working hour restriction and their impact on productivity. MBPJ allowed construction work from 8 AM to 6 PM on weekday, with restrict work on weekend and public holiday. This restriction limits the time availability for noisy or heavy construction activity and reduce the scheduling flexibility, which can affect the productivity if not properly planned. So to overcome this, several productivity strategies are adopted. So these include an efficient site layout, shorter material travel distance, clear circulation route, and the well-coordinated construction sequencing. So these measures help maximize the productivity within the permit working hour. Next, I will discuss the site space and material management constraint. After accounting for statutory setback, the remaining site area is limited. This space must accommodate the site office, welfare facility, material storage, waste skip, and equipment parking. Due to the space limitation, large-scale material stock piling is not possible. Without proper control, this could lead to congestion, safety hazard, and visual disturbance. To address this, designed and well-organized storage areas are provided. Material quantity are strictly controlled, and a just-in-time delivery approach is used to minimize on-site storage requirements. Lastly, I'll talk about the security and public safety consideration. The open residential environment increases the risk of unauthorized access and public accidents, especially involve children. This risk may also result in legal and reputational issues if not properly managed. So, to manage this risk, the secret perimeter hoarding and lockable material storage, control entry and exit point, and clear signal with physical barriers are provided. Overall, this security requirement directly influence the placement of site facility and the planning of internal circulation route, making safety and security as a key factor in the site layout design. So this is the site layout plan of the project. For this session, I will discuss the comparison of project duration and scheduling among the group members. Although all project plans are developed for the same double-story bungalow, there are clear differences in overall duration and scheduling strategy. So the comparison of project duration among group members shows significant variation, even though the scope and building type are identical. The overall project duration range from 191 days to 240 days. This difference mainly results from variation in planning concept, risk tolerance, productivity assumption, and the degree of task overlap applied in each schedule. So table summarizes the comparison of project duration, including the start date and completion date for each group member. Ong Jin-won recorded the shortest duration of 191 days, while Arnold Shasha has the longer duration of 240 days. The remaining project duration fall between these two extremes. Ong Jin-won project plan has the shortest duration of 191 days. This is achieved through an accelerated construction approach that overlaps major construction phases. By allowing concurrent activities, the project achieved higher time efficiency and reduced time-related costs. However, this schedule has very limited flow along the critical path. As a result, any delay in early activities such as substructure or superstructure works will directly affect the overall project completion date. This makes the schedule highly sensitive to disruption. Arnold Shasha project plan has the longest duration of 240 days. Each construction phases is larger completed before the next begins. While this extended duration increases preliminary and overhead costs, it provides the greatest buffer against unforeseen delays. This approach makes the project more flexible to weather disruption, minor labor shortages, and material delivery issues. Shao Yize project has a total duration of 212 days, which represents a balance between efficiency and manageability. The schedule spread work over a longer period with a lower daily workload. This makes progress easily to monitor and allow key milestones to be controlled more efficiently. Overall, the schedule is realistic and practical for site management. Yap Jiaxian project has a duration of 232 days and benefit from an early project start on 1st of January. This helps ensure that labor and material are secured before peak construction period. As a result, the workflow can run more smoothly, although the overall project duration remains relatively long. Xia Xia Shazina project plan has a duration of 235 days. The longer duration is mainly due to labor-intensive construction method and conservative productivity assumption. While this reduces pressure on individual trade, it increases dependency on sustained labor availability and extends the overall project duration. In terms of scheduling strategies, the group members demonstrate varying levels of task overlap, sequencing logic, and workload distribution. These differences significantly influence project duration, site management complexity, and exposure to the risk. This table compares the scheduling approach adopted by each group member, including task overlap level, workload distribution, strengths, and potential risks. Ong Jin Wen project employs an aggressive fast-track scheduling strategy with a high level of task overlap. Finishing work are allowed to begin while superstructure work are still ongoing. This approach maximizes the time efficiency and achieves the shortest completion period. However, it requires coordination between threads to prevent site congestion, safety risks, and potential reward. I know Xia Xia schedule follow a traditional linear sequence method, where each construction stage is complete before the next begins. This reduces coordination complexity and improves site safety. The clear handover between tracks also makes progress easy to monitor. However, this approach results in a longer overall project duration. Chaoizer's schedule strategy focuses on high-value, low-labor activities with strong emphasis on procurement and the use of specialized subcontractor. The lower work density simplifies monitoring and reduces daily management pressure. However, this strategy increases dependency on time material delivery, making procurement a critical factor in maintaining the schedule. Yap Jiaxian project adopts a balanced scheduling strategy with logical sequence and moderate task overlap. The early start provided an advantage in securing shared resources before peak demand period. However, strong monitoring during the early stage is essential to maintain this advantage throughout the project. Xia Xia Shazina's schedule is characteristic by labor-intensive and productivity-based workflow. While this approach reflects realistic site operation, it makes the schedule more exposed to labor productivity fluctuation and manpower shortage. This requires close supervision. Overall, Chaoizer's project plan is considered the most efficient among the group members. With a duration of 212 days, it avoids the excessive length of Xia Xia plan while being more manageable than Ong Jin Wen fast-track schedule. This emphasizes on procurement planning and specialized subcontractor reduce site congestion and daily workload while maintaining steady progress along the critical path.
Moving into our analysis of task sequences, it's important to note that while all team members adhere to the overarching construction life cycle, which progressing from preliminary and substructure to superstructure and finishings, with other distinct different in how each plan approaches the detail and overlap of this stage. We have categorized our project plan into three distinct strategy approaches. Firstly is the standard sequencing used by the Xia Xia and Chaoizer. Their plan prioritizes a linear flow, ensuring all heavy structural work is 100% complete before finishing work begin. These are traditional and low-rise approaches focus on quality control. Secondly is mobilization focus. The project plan of Yap Jiaxian and Xia Xia Shazina took a different route, providing much more comprehensive sequence for site preparation and early stage mobilization to ensure a robust project launch. For the aggressive overlapping, the project plan of Ong Jin Wen utilizes a fast-track approaches. In this model, the finishing phase begins while the superstructure is still in progress, significantly compress the overall project duration. Looking at our technical links, all plans correctly use finish to start for major steps like foundation and roofing. This is the safe way to manage handover between workers. We also look at other methods. For start to start, used by the Ong Jin Wen to overlap finish tasks and save time. For finish to finish, used by the Yap Jiaxian for the final stage. So link finish train to the final inspection, so the project only moves to handover once every small task is 100% done. For the start to finish, no one uses this, which is correct because it does not really fit physical construction work. In a nutshell, the project plan of Yap Jiaxian is the best option because she highlights here with finish to finish being used to link the completion operation finishing train to the final site inspection and only transits to the handover stage once all subordinate tasks has been fully completed.
For the resource allocation analysis, we compared how each member managed manpower and machinery. We identified three distinct approaches in our group. First, the ROPS management approach. Yap Jiaxian proposed a comprehensive engineering team. While this ensures excellent quality control, we found it offers an opportunity for cost optimization given our specific budget of Rm 850,000 ringgit. Second, the logistic approach. Annual and Chaoyizhe provide excellent detail on stand roles and material tracking. Third, the crew-based approach. On Jingwen used specific crew size like a team of 6 masons to justify the schedule. In conclusion, we decided to adopt On Jingwen's strategy as the master plan. It was the most balanced model. It provided realistic labor numbers without overhiring management, ensuring we stay efficient and within budget.
Lastly, we're going to make a comparison of milestone and critical path for each member project. Based on the table above, it shows the project initiation and project completion for each member project. So the firstly, I Know Shasha project followed an extended steady workflow over 240 days, allowing for buffer and greater recovery potential for critical path delays. Monitoring should aim to maintain momentum to avoid dragging into year-end holidays. The next one is Chaoyizhe's project. It utilized a high-value, low-labor workflow, focusing on expensive material and specialized subcontractors, leading to fewer work hour and low work intensity. This allowed for effective monitoring of key financial milestones through risks include budget constraint and material delivery delays. Next one is Jia Sheng's project. It employs an early stage balance workflow, beginning right at the start of the year to secure resources and avoid February congestion. Monitoring should focus on meeting milestones in January and February. Next is On Jingwen's project, features a fast-track workflow with a compressed timeline of 191 days and a heavy workload, making it the most brittle. Daily and aggressive monitoring is necessary as minor delays could jeopardize the completion date. Lastly is Shasha Shazvina's project. It is a labor-intensive with a significant focus on manual labor. Its large number of work hours complicates monitoring with potential for time and budget leak if labor productivity drops. In conclusion, we can see that Chaoyizhe project is the most manageable, while On Jingwen's project is efficient but require intensive monitoring to stay on track.
For Harmony Resident double-story bungalow project, there are 5 alternative schedules were evaluated. It is aimed to identify most realistic and achievable schedule. The evaluation criteria are: firstly, project duration, scheduling strategy, task sequence, dependency logic, resource allocation, and lastly is critical path management. Chaoyizhe project plan is selected as best schedule because it is more realistic and achievable option. It is also supported by the balanced duration, logical sequencing, manageable risk, and effective monitoring. For the project duration comparison, Chaoyizhe, which is 212 days, is balanced, while On Jingwen project plan is 191 days. It is too fast and high risk. For I Know Shasha, it's required 240 days. It took more time and higher cost. So, balanced duration can reduce the delay risk. For scheduling strategy, Chaoyizhe project plans require high value and low labor approach. It focuses more on subcontractor, which benefit is less congestion, easy coordination, and lower supervision. It is more stable than labor-intensive plan. Next is task sequencing. Linear construction sequence where it is go with preliminaries first and then substructure, superstructure, and lastly finishes. The benefit is it will less rework, improve safety, and better quality. It also prevent overlapping, increase risk. Next is dependency logic. It is mainly finish to start. It also ensures that logical work order. The benefits are safer work environment, clear handover, and better workmanship. For monitoring and controlling criteria, Chaoyizhe project plans has low work density. It more focused on procurement and financial control. The project also easy tracking and early risk detection. For fast track, needs close supervision. Lastly, resource allocation. Chaoyizhe project plan have strong material tracking while limitation of labor. The improvement can do in this project plan is why not can add a new rule classification and maintain schedule logic. So the conclusion is Chaoyizhe schedule is the most realistic, technically flexible, practically achievable, and the recommend can do for this project is baseline program and minor improvement is can add more labor detailing.